Okay, so again, did you guys get this one?
Yes, sir.
All right, so who's still trying to analyze on how we've come up with, on this one? So you can ask a question on how did we get this expression or that, or anything that it's confusing you.
Sir,
Yes?
how do we know po when to apply yung reverse implication sa solution?
Hmm. So your basis is always your goal. Okay, your goal here is to have uh, this expression to become your final answer in here, because you're trying to prove that this expression can be proven by the use of laws of logic, that they are equal with this kind of expression. So as you can see right here, from second step, yeah, first, second, Q or not P. If you're going to compare this one, Q or not P, the only thing that is different is the first one, which is P, not Q, and then the second one, which is P, connectives. So from here, we can actually apply the implication. So from or, it can be reversed into conditional, and then as you can see right here, our uh, hypothesis is negated if you're going to apply implication. So just reverse it. Okay, it will become reverse also. I mean, it will become negated also, or it will become positive, or vice versa.
Okay, sir. Thank you po.
Parang iniisip ko, I was thinking, did I explain it properly? So even me, I was confused with my explanation. Anyway, so again, your goal here is to prove that this one is equal to this one. Okay, so that is why we've come up with the reverse implication. Okay. All right. So anyway, let's move on to exercise number 2. So we have this expression, very long. So we should prove that this one is equal to this expression. Okay. So as you can see right here, from 1, 2, 3, 4, 5 expression, 5 variables rather, to 2 variables only. Okay. So from here, we have here the yellows, highlights, okay, or yellow bold letters rather. So they are the changes on every step that we'll be doing. So these are your guidelines on what are the things that happen on our expression. So as you can see right here, from the entire statement, it just copied into this. So I guess they are just the same. So yeah, the same. And then from here, we distribute the negative sign. So we applied here distributive law. So negative to negative. And then nothing has changed. This one. So from or, it became and then negative times negative again, which is now not q. Okay. And then from here, you can apply negation. So negative times negative will become positive, or will just simply cancel. So that is why we have this kind of expression now. And then the same with this one, okay? So negative times negative will become positive. Or you can just simply cancel that one. So now we now only have this kind of expression, okay? So smaller. So from 5, it became 4. 1, 2, 3, 4, 5. I'm sorry. From 4, still 4, okay? I counted this one as part of the variable. So this one is a connective, not variable v. Variable v. This one is just a connective, which is or. Okay, so it's still the same, but we've lessened the connectives. Okay, so from here we applied associative. Okay, so as you can see right here, we have the same connectives, the end and then end. Okay, if you have this kind of setup, then you can apply associative. Okay, so you can transfer this statement or close and open parenthesis into here. Okay, so that is why we have now P or Q and R and Q. And then from here, we've applied commutative. Okay, so again, commutative is just exchanging, okay, the positions of your variables. So from R and Q, it became Q and R. All right. And then again, apply associative, which is now PRQ and Q and R. Okay. So why did we do this one? So that we can apply absorption. So again, this is where absorption comes in handy. So again, absorption from 3 variables, it will become one variable only. So as you can see right here, we have a total of 4. Okay. So you should think on what are the things or what are the formulas that can shrink from 3 variables into 1 or from 3 variables into 2. Okay. So one of them is absorption. So once we've come up with this kind of setup, PRQ and Q, okay, so we can now absorb this expression into Q only. So the remaining expression is the end and then R only. So you can just copy those. So Q and R. So from there, we have already proven that this expression is equal to this expression. Okay, so we've applied 1, 2, 3, 4, 5, 6 laws of logic. So you can base our answers with the screenshot that we have taken a while ago. So I'll give you guys a minute or 2 minutes to analyze this one on your own. And that's so that you guys can convince yourself that they are correct. And so while you're analyzing this one, so let me know if you have already got it or if you have a question or clarification. So feel free to ask me anytime. So again, the highlighted yellows are the changes on every step that we are doing or that we've done rather. Is that you, Miss Maxine, who speak? So I have a message here coming from your classmate. So, sir, how did you cancel out the negative negative in the first solution? Where is that one? Here? This one? Is this what you are talking about? By applying negation or this one, double negation. So negative times negative will become positive. Okay. So I guess that's the same with our call this one. Natural math. What do you call that one? Basic math. Okay. From our basics, right? So negative times negative will become positive. So the same with this loss of logic. If we have two negatives, it will become positive. So that's how we've got, or that's how we've canceled these two negatives. Okay, but take note, okay, we've actually distribute the negative first. So negative will be distributed in this statement. So that's why we have negative times negative, and then this or became n, okay, because we've negated this one also. Okay, and then negative times negative. Okay, all right. So that is why parentheses or brackets in here are very important. Okay. So as long as you know the fundamentals of mathematics, then you will not lose on how to solve things properly. Right. So any other concerns? So who here are already done in analyzing, and then you have already proven that this one is equal to this expression.
Clear na po, sir.
So clear
Clear
coming
na
from,
po.
okay, that's good coming from Misumo. How about the others?
Clear, sir.
Clear, sir.
Okay. How about to those who are still analyzing on how we've come up with this result? Anyone? Mr. Abdul? Mr. Abdul Wahab, are you there?
Yes, sir.
Mr. All right, so you are still trying to analyze, am I right?
Yes, I'm going back through the law law of logic.
Yeah.
I'm memorizing.
Okay. Actually, you don't need to memorize, okay, since you already have your reference. All you need to do is familiarize and then, um, you know, analyze on how we've got those expressions. Like for example, I've explained some of them, wherein they are comprehensible by just by using our basic mathematics. But some of them, like number 21, 22, and then 23, are hard to comprehend with the use of basic mathematics, since we have a derivation on how they come up with those kind of expression. Okay. So for now, just use this one. Where are we now? Okay, refer on our uh, names on, say, distributive. So in here we apply distributive law, and then in here we've applied negation. So that's why we've come up with this kind of expression. And then in here we've applied associative. So that's why we have this kind of expression, and so on and so forth until we've come up with this final result. All right, so how about the others? Other than Mr. Abdul Wahab, who's still trying to analyze number 2. So it would be also better if you have your paper with you and then your pen, so that you can, practice at the same time. All right, so to those who didn't understand this one yet, or to those who didn't get this one on how we've come up with this result, so I'll give this one as your assignment, okay, but not recorded, okay. I'll just leave this one as your uh, self, okay, this one, self-study, self-study assignment, but not recorded, okay. Are we good on this one, Mr. Abdul? So try to analyze this one again once we're done with our meeting. Okay, since we cannot wait 5 or 10 more minutes for the others who didn't understand this one. So just try to catch up, okay? Hello? Can you hear me, Mr. Abdul, or the
Yes,
others?
sir.
All right, so we
Yes,
will
we
now
can hear
proceed
you.
to number 3, okay? So don't worry, we will do it slowly, okay? So from here, no, this one is different already, okay? So in here, we are not trying to prove this one anymore, that this one is equal to another kind of expression. So in here, we'll just simplify this one. So we will simplify as the maximum or to the fullest. So as you can see right here, we have 2, 4, 6, 8 total of variables into false result. Okay. Or if we can come up with, you know, 2 variables, then that's okay. If we cannot uh, simplify that one further. But in here, we can come up with a single answer, which is false. All right. So from here, just copy the entire statement. And then from here, we distribute the negative sign. Okay. So negative times negative became positive. And then negative times and became or. And then negative times negative became positive. So that is why we've come up with P or Q. Okay. So as you can see, we didn't change anything on the other expressions. So we've copied this one into this. So still the same. And then the second step is we've applied or we put brackets. Okay. So bracket here and then bracket here. So why did we do this one? So that we can apply, okay, what do you call this one again? We can apply inverse distributed, okay? So you're going to go back to distributed properties, this one. From 3 variables, it became 4. But since in our example, from 4 variables, it became 3. So that's why I've called it inverse distributed properties. Okay. So let's go back to example number 2. I mean number 3. Sorry. So as you can see right here, the letter Q is the common variables. Okay, because P here has a positive sign and then a negative sign. So our common variable here is Q. And then again, for you to be able to know the positions of your connectives, your OR and then AND. So whatever is the one that is inside will become is the one that is inside. Oops. Am I right? Inside became outside. Yeah. So sorry. Inside became outside. And then outside became the one that is inside. Right? And then here we put the Q on the outer part of our expression since this is our common variable. And then in here we have the positive, which is this one, and then the negative, which is this one. So it's quite hard to do this one using logical thinking because it's the inverse. We only know to expand. So that's the common way for us to do the mathematics from smaller to expansion. But from expanded into smaller, that's quite unnatural for us to do. So in here, you can base this one to our reference, which is number, where is that? Number 5 and 6. Okay, so from here to here, from here to here. All right, so the same with this expression. So we applied inverse distributed properties from 4 variables into 3 variables. And then in here, our common variable this time is negated q. Okay, so negated q. So that is why we have the negated q outside of this expression. And then p is this 1, and then negated p is this 1. And then the what is inside will now become the what is outside, and then the one that is outside is now the one that is inside. Okay. So that's why we've come up with this kind of expression. Did you guys get this one so far? Or you guys are still trying to analyze this one?
Okay. Okay, gets sir.
All right. Okay, very good. How about the others who's still trying to analyze up to the step number 3 of our solution? This one. So let me know, so that if none or if all of you have already get on how we've come up with this kind of expression, then we can now proceed to the next one.
Done, sir.
Okay. So very good to those who have already get this one.
Done, sir.
All right, very good, Miss Faye. Okay, how about the others? Mr. Carl Fred, Mr. Geneza, Mr. Lapsan, how are you guys doing?
Understood, sir.
Okay lang, sir.
It's very good then. Right, so I hope the others also get this one. Okay, so next is this one. So we have here p and not p. As you can see, we have two distinct variables. And then if you're going to analyze this one, if we have a true value for p, it will become positive. And I mean positive. It will become true and then false, or vice versa. Okay. And if we have false in this statement or in this kind of setup, which is and conjunction, the result will be always false. Okay. So the same with this one, right? So this one we've applied, I forgot the name, P and not P. We've applied inverse laws for this solution. Okay. So just by applying inverse law, okay, we've come up with false result. Okay. And then from here, so if you're going to take a look on this one, we can actually do the inverse law of this one, of the distributed properties. Okay, so we have a common variable, which is f, and then we have the q, and then not q. Okay, so this one fits perfectly for our distributed properties. Okay, so again, we call this one inverse distributed because from 4 variables, it will become 3 variable. Where is it? Right? So that is why we have this kind of expression. And then if you're going to analyze this one, so we have this kind of setup again, which is suited for inverse law. So the result will become false, just like this one. And then false or false is now false. Okay. So in here, by applying the truth table of the disjunction. Gets or not yet?
Get, sir.
Gets, sir.
Okay, very good, Mr. Maswelda.
Gets na, sir.
And very good, Mr. Raster. Raster Vince Pulmana, if I'm not mistaken. How about the others?
Gets po, sir.
Understood, sir.
Gets na rin po, sir.
Understood.
Understood po.
All right, it's good.
Gets, sir.
Actually, I would say that it's easier to teach in a face-to-face setup because I will see your faces. And let's say if did you guys get this example? I will know the expressions of your faces. Like for example, some are still like, looking firstly on the blackboard or the whiteboard and then trying to analyze what happened on that part. So I already know that that student didn't get some of the steps. And in here, in my case right now, so I'm only seeing your names. Okay, so I don't have an idea whether you guys are really understanding the one that I'm trying to explain here or anything. I have no clue at all. So your response rather is very important for me so that I know that you were listening and you guys are really trying to understand what I'm trying to explain here. Because I know this one is not that easy. So yes, I can say or I could ask right away, did you guys get this one? And I've just explained it a minute ago, and then just by asking that one will not convince me that you guys really get this one because I don't know the expressions of your faces. Because some of you will just say, yes, sir, I've already got it. Yes, no question, sir. Understood, sir. But in reality, you didn't really get it. Well, anyway, so I hope that your answer is reliable enough for me to believe that you guys have really understood this one. And to those who are not responding, so I hope that you guys are really there, okay, and uh, trying to understand what we are trying to explain here. Okay? Because I'm afraid that you guys are not responding because you are not really there. Okay. Anyway, so we have video exercise number 4. We're in the same with exercise number 3. So it is asking us to simplify this one. Okay. So from 6 variables into 3 variables. So let's see what happened or how did it go. So just copy as it is. And then the yellow highlighted text are the changes or the things that we've changed from the past solution or from the past expression. So from here, we've just distribute this negative into inside of those statements or inside of those parentheses. So this one became not Q or R. And then this or became N since that's the negated connectives of or. And then this supposedly you can cancel this one already, but just for you guys to see the complete solution, so just put here not or negative times R or P. Okay, so that is why we have this kind of setup now. So did you guys get this one or no?
Gets, sir.
Yes,
Yes,
sir.
All right, very
Well,
good. So
sir.
this one is super easy. Next, so what we did here is we distribute again. Okay, distributed properties. Distribute the negative inside of the parentheses. So not Q, and then this or became N, and then not R. Okay, and then still the same and then this not, okay, or not will just be simply canceled. Okay? So that is why we not only have R or P. Okay. And then from here, we can actually apply the associative, if I'm not mistaken, wherein you can remove the parentheses so that we can have this kind of setup. Okay. So in associative, you can, you can remove, or you can call this one, move the position of your parentheses from here to here. Okay. So in this case, number 4, in this case, we've actually removed this parenthesis. Okay. So that we can have this kind of setup. Okay. And then apply, call this one, number 2, or number 1. You can apply commutative. Okay. So P or Q is equal to Q or P. So we've just interchanged this not Q into here, and then this not R into here. Okay, so they've just swapped. And then from here, what happened next? P or not R. Okay, so from here, we've applied absorption. Okay, so from 3 variables into 1. Yes? Can you guys still recall what is absorption? So use your
Yes, sir.
so try to verify whether they have the same setup. But before we finish this one, so I will stop right now since we now only have 20 seconds, I guess. So I will end our meeting now and then just join on our part 3. Okay, so goodbye for now, and then see you on part 3.